All right, so I believe that we're doing more of the same stuff here, okay? Where we're trying to make connections between equations and what they are supposed to represent. All right? So this says a student has had a collection of baseball cards for several years. Suppose that B represents the number of cards in the collection, and it can be described as a function of t, which is time in years since the collection was started. Explain what each of the following equations would tell us about the number of cards in the collection over time. Okay? So yeah, and that's the Matthew that we want again when, maybe you guys aren't going to retake that test. I should have asked the counselors there at lunch today. Um, just a quick, I got this. Just bam, 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 bam. That's there. Thalia, what does the equation b equals 200 plus 100t tell us about the number of baseball cards that this student has over time? Okay, what was that, Nathan? Can you say that again so Talia can hear you? Okay, so 200 is the starting amount of cards. So this means she had 200 cards to start with. And then what's says Leah to the amount of cards in her collection? Yep. Yeah. Makes sense? Okay. 200 cards to start with, that's the y-intercept. The slope is 100, it's positive, so it's going up by 100 every year. So Dylan, you want to piggyback on that? What does it mean if it's b equals 100 plus 200t? Yep. Make sense? You guys are going to dominate this test. When? Yo, no say. Let's see. Yo. Oh, okay. What just happened? You're thinking? Okay. Keep it posted. Nathan? How about if it's, okay. Okay. All right. Nice. You know she's selling them. She's getting rid of them. She could be burning them. You burn them because the baseball cards were given to her by her now ex-boyfriend. So, who was also what? No, who was also a baseball player. Yeah, so again, the number by itself is the y-intercept, how many cards she's starting with. This time the slope is negative, so that means one way or the other, yeah, the number of cards is going down. Yeah, you're right. We don't really know what's causing her collection to go down. We just know that it's going down. Luis? All right, starts with 1,000 cards. Gets gets rid of 200 per year. Okay? Easy peasy, yeah? It is a little toasty, isn't it? All right, so next one. Is this on your thingy? Yes? Okay. All right, so now we're going to be given some different situations, some different real life situations, and we're going to decide whether the situation could be modeled by the equation y equals 2x plus 5. All right? So the first one says there are initially 5 rabbits on the farm. Each month thereafter, the number of rabbits is 2 times the number in the month before. It would tell us how many rabbits there are after X months. Love it. Matthew, what do you think? It's a yes? Because why? So the 5 is the y-intercept again, so 5 is definitely the starting amount. Dude, I don't know. I'm just writing words, okay? I gotta question everything. Why you gotta always fight the man? Can't you just be a good little soldier? What is the equation that it's saying? Jaron, help me out. Right, so you hit it on the head with what this should be represented by. Can you give me this equation? What it should look like? What did you say? 2, not. It starts with 5 because that's how many rabbits we have to start with. It's not plus because what's happening to the number of rabbits? They're multiplying, okay? So, Matthew, no. It doesn't fit because they're multiplying by 2 each time. What is the equation that we use for when you are multiplying? Jaron? Yeah, the nth power, but what's being raised to the nth power? Not the 5. The 2. Good. Nope, that's all right. I'm just going to go ahead and use x, okay? So 5 is the starting amount, okay? But since it's multiplying by 2 each time, that means that we're going to use a exponential equation, not a linear equation. So sorry, Matthew, no go. Yeah, it is. What? Okay, what? Sure, man. Yeah. You bet. Right, the equation is a way, yeah, that you can show your reasoning. All right, Matthew feels bad because he had that one stolen from him by Jaron. So let's try another one. Joaquin. Well, Phoenix, right? Joaquin Phoenix, is that how you say his name? Joaquin. Okay. Don't hate on us, Louise. Come on. Joaquin. Okay. Joaquin earns two. Joaquin. Okay. Joaquin earns $2 for each magazine sale. Each time he sells a magazine, he also gets a $5 tip. How much money will he earn after selling X magazine? So does 2x plus 5 fit that one? Yes? You're what? Okay, 2 times the number. Okay. There you go. $5 tips on each magazine that you sell. Yeah, so that means no. Yeah, so each time he sells a magazine, he also gets a $5 tip. that means that you get $2 per magazine plus another $5 for each magazine. If it's 2x plus 5, then that means you're in a situation where you're only getting 5 once, not each time you sell the magazine. Yeah. So basically, I was just saying, they're making $7 a magazine. Yeah. So that's not so bad. Not so bad. Yeah. Right. Okay, Jaron, unless Matthew steals it from you to get sweet, sweet revenge.
Yes.
Sandy charges $2 an hour for babysitting. Parents are charged a one-time fee of $5 if they get home late. Assuming the parents arrived late, how much money does she earn for X hours? No, one-time thing. So if you say you're going to be home at 10 o'clock, Jaron, and you walk in the door at 10:01, you give me an extra $5. If you say you're going to be home at 10 o'clock and you walk in the door at midnight, you give me an extra $5. If you say you're going to be home at 10 o'clock and you don't show up until like a week later, I get an extra $5. That's it. Yeah, there'd be some other issues there, yeah, but still, in this structure, they would only get the $5 once, so that means it's a yes. So the 2x plus 5, this is the per hour, and this is the yeah, the late fee. Well, then they'd still only get, I mean, they get $2 an hour, I guess, so there'd be, that clock would be rolling, yeah. $2 an hour for babysitting? Yeah, I wish. Okay. All right, Weston. A sequence of integers. The first term of the sequence is 7, and the difference between any consecutive terms is always equal to 2. No. Well, the first term in the sequence is 7. So if I plug in 1, then I get 7. Okay? The next thing is if I plug in 2, it says the difference between any consecutive terms is always equal to 2. So then I get y equals, no, the difference is 2. You know what? No, I didn't think about that. You're right. It could be 5. Or it could be 9. Right? Because the difference, because the difference between these two numbers is 2, but the difference between these two numbers is also 2, huh? So we don't know which way it's going. Yeah, so that's going to be a no. I was going to say that it was a no because we could end up using decimals in here, and then you wouldn't get integers, but I like your inadvertent discovery better. So Thalia, it just means you start with the number 7, and you either go up 2 or down 2 each time. And then, so since Weston said that you could go up or down, that means that the equation won't fit. Can I see that again? Oh, nice. What does it say? Happy tree? Happy tree? Where'd you get those? Nice. Wow, I need to upgrade my sock collection. I got nothing nearly as good as that. All right, Matthew, back to you. Sneak Preview is a members-only video store. There's a $2 initiation fee and a $5 per video rental fee. Why not? So what would be the equation for this? Well, that's what we got, 2x plus 5. 2x plus 5x. Class. How many times you... There you go. Because the the 2 only happens one time. Okay, that's your initiation fee is $2. The $5 happens with every video rental. So in that equation, they have the slope and the y-intercept switch. It should be y equals 2 plus 5x. Okay, right, so that's a no. And then like Nathan said, it's easier if we just explain by writing what the equation should be. Okay? You okay, Dylan? All right. Okay, how about this one? Andy is saving money for a new CD player. He began saving with a $5 gift and will continue to save $2 each week. Thalia? Thalia? That's a yes. Yep. So 5 is how much you're starting with, and then you're saving an extra $2 a week.
Yes, awesome.
Oh, that's the gal, the exchange student from South Korea. Her name's Jawan. What? All right, so let's switch gears here. Now we are coming up with the equation from the beginning all by ourselves. So we're done with the whole y equals 5x, 2x plus 5 thing. So this says the checking account is set up with an initial balance of $4,800 and $400 is removed from the account each month for rent. Okay, Jaron? What? Jaron? Write an equation. $4,800 in your account, $400 is removed each month. Okay, and they want us to use M for months. Okay, you guys good with that? You're starting with $4,800, you're taking out $400 a month. Okay, this one has another part to it, which is figure out when the account balance will reach $2,000. So, Dylan, when is that going to reach $2,000? How many months will it take? Yep. Never. You're starting with $4,800 and you're going down. Yeah, going down to get to 2,000. What's an equation that we could write to figure that out, Jared, or Dylan? So this is my equation, what I want to set this equal to. Yeah, I want this to equal 2,000. So what do I do now? Take away, right, so if I subtract 4,800 from both sides, then that's basically what you're saying is that you have to figure out how long will it take for you to subtract $2,800. Yeah, so the way that you find that is you divide those two things. Yeah, so it'll take 7 months. Yep, you got it. Well played, sir. Okay, same problem. Checking account is set up with an initial balance of $4,800. $400 is removed from the account each month. Make a plot of the balance after M months for 1, 3, 5, 7, 9, and 11. Oh, good thing I do. Yeah, so let's just, you guys can just sketch this or something. What should we go by on the y-axis to get to 4,800? 200s? 2, 4, 6, 8, 1,000, 2, 4, 6, 8, 2,000, 2, 4, 6, 8, 3,000. Not going to make it 500. How about 400? 4, 8, 12, 16, 20. Yeah, I'm going to go by 400. But I want to land on 4,800 exactly. Yeah, weird, huh? I wanted to go by 500, but Matthew insisted that we go by 500 instead. Okay, that's pretty darn good. I can drink boiling water. I can legitimately drink boiling water. Yeah, I can. I just boil some water in a microwave in a glass and drink it. I don't know, or on a stove, whatever, it doesn't matter. Just take some boiling water, just drink it. Yeah. Yeah. Oh, you didn't say that. When in the life of a flamingo will they come across boiling water? There's no geysers in Florida, are there? Is there geysers in Florida? Florida? Like they can drink, so they can drink super hot water, is what you're saying. Okay, so how much money does this person start with in their checking account? 4,800. Watch this, Matthew. How much is it going down by each month? 400. Oh, good thing I went by 400s. That just happened. So now this is going to be... You're not? No, I'm just asking for confirmation. Okay, so there's my graph. Make a plot of the balance after m months. 1, 3, 5, 7. Oh, I put too many of them on there. 1, 3, 5, 7. Oh, man. You did it for everyone, so it doesn't matter. 1. Okay. So there's the points for 1, 3, 5, 7, 9, and 11. Dylan, how many months did you say that it would take for? Okay, so this point right here represents 7 months and $2,000 left in the account. Okay? That was it. Okay, that was kind of weird. No, that was it for that problem. I thought they were going to ask more questions about that. We're about to. We got 1, 2, we got 4 more. All right, next one. Write an equation using function notation to model each of the situations. Cedric and Josh both ordered the same size pizza at Marco's Pizzeria. However, they ordered different toppings. Marco's charges an additional fee for toppings, but at Marco's, all the toppings cost the same. Cedric got pepperoni, banana peppers, and black olives on his pizza, and it cost him $15.74. So he got 3 toppings. Bless you. And they cost $15.75, 74 cents. Gesundheit. Bless you. Josh ordered mushrooms and eggplant on his pizza and paid $14.49. Using this information, write a function C that gives the cost of a pizza as the number of toppings ordered. Okay? So, how much does each topping cost? How'd you get that so quickly? No, it's close. It's close. Yeah. Oh, I thought you actually figured it out. You're just guessing. Okay. How much does each topping cost? Nope. Let's not just guess. How did you get $1.25, Matthew? Okay, if this has 3 toppings and it costs $15.74, and this has 2 toppings and it costs $14.49, that means one topping costs whatever $15.74 minus $14.49 is. Does that make sense? Yeah. Because one additional topping in the pizza costs $1.25 more. All right? Here's the tough part, though. Now we got to figure out how much the pizza with no toppings costs. So 3 toppings, $15.74. 2 toppings, $14.49. 1 topping. How would you figure out how much a pizza with 1 topping would cost? Subtract $1.25. So will you do that? $13.24. And then if we go to 0 toppings, then you subtract $1.25 from that and you get $11.99. All right, so now we have the information that we need to write a function. So they asked us to use function notation, so I'm going to do C, because it says a function C for cost as the number of toppings ordered equals what did we start at? Nope, what did we start at with 0 toppings? Yeah, $11.99 plus $1.25 a topping. Okay, so that problem was considerably more difficult because they didn't tell us what the starting point was, and they didn't tell us what it was changing by. We had to use the information that they gave us to figure that out ourselves. If they don't tell you, they just don't tell you the starting value. What do you like, work at a pizza place or something, Mr. Smart Guy? Oh, you did? Oh, I didn't know that. When did you quit? How come? Boring. No free time. Yeah. Okay. All right.